Hi there, Bear Branch Junior High. This is Mrs. Tucker with a video review of Chapter 4, Proportions and Similarity. This is Part 1. I want to make sure that you guys show your work, and if you don't have enough room to do your work on your worksheet, then you need to do it on a piece of scratch paper. Okay, let's get started. It says for questions 1 and 2, express each ratio in simplest form. All right, number 1 says 95 girls to 105 boys. I set up a ratio of girls to boys. I set 95 over 105, and I noticed that both of those are divisible by 5. So when I divide both sides, both the top and the bottom by 5, I got 19 girls to every 21 boys. All right, for number 2, let me flip this over. Number 2 says we have, let me get that in the picture there, 82 out of 104 students. So when I set up that ratio, I have 84 out of 144, and I notice both of those are divisible by 12. So when I divide the top and the bottom by 12, I got 7 out of 12 students. Number 3. Number 3 says, let me cover up all the answers here. I don't want to give away all my secrets. Express the rate 296 miles in 5 hours as a unit rate. Okay, so I set up a ratio of 296 miles over 5 hours. I'm going to take 296 and divide by 5. And when I did that, I got 59.2 miles per hour. That's what you got. Okay, did you guys notice there's an answer bank at the end of this worksheet? Great. Number 4 says, let me hide the answers. Which is the better buy? 12 reams of paper for $24.50 or 5 reams of paper for $15.25? Explain your reasoning. That means show your math. Okay, so when I set up $24.50 for 12 reams and I took $24.50 and divided by 12, I got $2.04 per ream. I'm going to do the same thing with $15.25 for 5 reams. When I take $15.25 and divide by 5, I got $3.05 per ream. And obviously $24.50 for 12 reams is the best buy. All right, on to number 5. Number 5 says, Susan makes $15 per hour to shovel snow. Is the amount that Susan earns proportional to the number of hours that she works? Hint, make a table and check cross products. Okay, I can make a table. I'm going to compare hours to dollars. Those are the two quantities that change. For 1 hour, she's going to earn $15. How much will she earn for 2 hours of work? How about 3 hours? Yes, for 2 hours of work, she earns $30. For 3 hours of work, she earns $45. Now I'm going to check cross products. When you do that, you see that 2 times 45 is 90, 3 times 30 is 90. Those cross products are equal. If you take 30 times 1, that's 30. 2 times 15 is 30. So yes, this is proportional. Number 6. If I can flip my paper over. Okay, for questions 6 and 7, solve each proportion. Well, to solve a proportion, you know that cross products are equal. So 16 times b is the same as 9 times 48. 9 times 48 is 432. If 16b equals 432, then I need to divide both sides by 16. And 432 divided by 16 means that b equals 27. Alrighty, on to number 7. Oops, if I can get this going. Number 7, there's that proportion. I'm going to cross multiply and set my products equal to one another. So 40 times f is the same as 12 times 55. Now I've got to figure out what 12 times 55 is. Well, that's 660. So 40f equals 660. I have to divide both sides by 40. So 40 equals 660, or f equals 660 divided by 40. and I notice both of those are divisible by 10. That's why I crossed off the zeros. So if you take 66 and divide by 4, you should find out that f is equal to 16.5, or 16 and a half. Number 8. Number 8 says, Aretha swims 3 laps every 5 seconds. How many laps will she swim in 120 seconds? Well, you can see that I put together my little word ratio here, laps compared to seconds, and I'm going to pop in the numbers I know and solve for the ones I don't. So when I did that, I put 3 laps in 50 seconds has to be the same as x over 120 seconds. Cross products are equal in a proportion, so I cross multiplied. Now I have to take 3 times 120, which is 360. If 50 times x is 360, then x has to be 360 divided by 50. I noticed that both 360 and 50 are divisible by 10, so I crossed off the zeros, and 36 divided by 5 is 7.2 laps. Did you get that? Great. Okay, on to number 9. Number 9 says, determine whether the pair of polygons is similar. Well, if the polygons are similar, then side lengths will be proportional. So I'm going to set up a proportion of the side lengths, and I'm going to check cross products to see if they're equal. And I set myself up a little word ratio. I'm going to compare small lengths to the big lengths. So 3 in the small corresponds to 6 in the big. Go back to the small, I chose 4. 4 in the small corresponds to 8 in the big. So when I cross multiply, 3 times 8 is 24. 4 times 6 is 24. My cross products are equal. So yes, those two triangles are similar. All right, for number 10, the last question for part 1. Number 10 says, the pair of polygons are similar. Write a proportion to find the missing measure, then solve. Okay, once again, I'm going to set up a little word ratio. I like to compare my small lengths to my big lengths. So I picked x in the small, corresponds to 6 in the big. I went back to the small and I chose 2 in the small equals 5 in the big. So when I cross multiply, I got 5 times x is the same as 6 times 2. 5x equals 12. Divide both sides by 5, and x equals 2.4. See you in part 2. Hi, this is part 2 of Mrs. Tucker's video review of Chapter 4, Proportions and Similarity for Bear Branch Junior High, 8th grade. All right, question number 11 says, for questions 11 and 12, the scale on a map is 1 inch equals 575 miles. Find the actual distance for each map distance. Okay, well, for number 11, our map distance is 3 1/4 inches. So I'm going to set myself up a little ratio, and I'm going to include my units. I said, since my scale says 1 inch is 575, 1 inch is the same as 575 miles. So 4 1/4 inches, I decided to change to a decimal. 3.25, did I say 4? 3.25 is the same as x many miles. So I'm going to cross multiply to solve. 1 times x is x. That's got to be the same as 3.25 times 575. Do the multiplication. When you multiply those out, you find that x equals 1,868.75 miles. Let me put an I in there. Miles. Okay, for number 12, we're going to do the same thing. This time they want to know the distance if it's 7.5 inches on the map. So once again, set up my proportion. 1 inch is the same as 575 miles. So 7.5 inches has to be how many miles? Cross multiply, 1 times x has to be the same as 7.5 times 575. Multiply 575 times 7.5, and you should get that the distance down the highway is 4,312.5 miles. Did you get that? Good. Let's go on to number 13. Number 13. Okay, let's see here. It says, Triangle ABC has vertices A, -4, 3, B, 2, 5, C, 6, 10. Find the coordinates of its image after a dilation by scale factor of 1/2. Well, that means that each one of the coordinates for each one of these points is going to be half as big. So we're going to multiply each one of these coordinates here by 1/2. So when I do that, -4 times 1/2 is -2. And 3 multiplied by 1/2 is 3/2, or 1 1/2. So A prime is -2, 1 1/2. When I take 1/2 of 2, I get 1. If I take half of 5, I get 2 1/2. So B prime is 1, 2 1/2. When I take half of 6, I get 3. When I take half and multiply by 10, I get 5. So C prime has to be 3, 5. Is that what you got? Yeah, that's not too hard. Let's go on to number 14. Number 14 says, in the figure below, triangle x prime, y prime, z prime is a dilation of triangle xyz. Find the scale factor of the dilation and classify it as an enlargement or reduction. Well, this one right here is xyz, and the bigger one is x prime, y prime, z prime, so it has to be an enlargement. I gave you all a little formula that said your scale factor is your new length divided by your old length. So I went, and the new length is those that are marked with a prime. So this line right across the top that I've highlighted yellow, I counted how many spaces it was from x prime to y prime, and I found out that was 10. Then I counted from x to y, and that was 5. So 10 divided by 5, that gives us a scale factor of 2. Scale factor of 2 gives us an enlargement. Let's move on to number 15. Number 15 says, playground. The triangles formed by the slide and the person are similar. How tall is the slide? Here's the person. Here's the height of the slide. I've got a triangle embedded inside of a triangle, so these two triangles have to be similar. I'm going to set up a proportion. I'm going to pick a length in the small, the 42. That's going to correspond to x in the big, and 45 in the small corresponds to 78 in the big. So to solve for x, I'm going to cross multiply. 45 times x has to give me the same thing as 42 times 78. What is 42 times 78? When I multiplied it out, I got 3276. If 45x equals 3276, then I have to divide both sides by 45, and x equals 3276 divided by 45. And when I did my division, I found out that x was 72.8 inches. Is that what you got? Great. Let's go on to 16. 16 says, a road sign casts a shadow that's 4 feet long. At the same time, a 6-foot man standing next to the sign casts a shadow that's 2.4 feet long. How tall is the sign? They did not give you a diagram. I highly suggest you draw your own. Here's my road sign, and here's my man, 6 feet tall, casting a 2.4 foot long shadow. Road signs casting a 4-foot shadow. Anytime shadows are being cast, triangles are similar. So I'm going to set up my proportion. 6 in the small corresponds to x in the big. 2.4 in the small corresponds to 4 in the big. I'm going to cross multiply to solve. 2.4 times x gives me the same thing as 4 times 6. 2.4 times x has to be 24. So I have to solve for x, I have to divide both sides by 2.4. 24 divided by 2.4 gives me 10 feet. Is that what you got? Great. Let's go on to 17. 17 says, the tables show the amount of rain in Sean's rain gauge at selected times during a recent storm. Find the rate of change in rainfall between 2:10 and 2:15. Well, I have marked over here that time is your x and inches of rain is your y. And I've given you the formula that says rate of change is the change in your y's divided by change in your x's. So between 210 and 215, my y's increased by 0.5, my x's increased by plus 5 minutes. So I've got 0.5 inches over 5 minutes, that's supposed to say minutes, and 0.5 inches in 5 minutes simplifies when you do the long division. That's 0.1 inches per minute. That's an increase of rain of 0.1 inches per minute. Okay, let's go on to number 18. I'll just flip this over. Whoops, where is number 18? 18's right here. All right, we're going to do the same thing here. It says the points in the table lie on a line. Find the rate of change of the line, then graph the line. Well, you can see I graphed the line first. So here we can do change in our y's over change in our x's, or you can do rise over run. So I notice that my y's are decreasing by 1 each time, as my x values are increasing by 2 each time. So the change in my y's are -1, the change in my x's are +2. -1 divided by +2 gives me a rate of change of -1/2. Is that what you got? That's great. Okay, let's go on to number 19. Number 19 says, find the rate of change of the line and interpret its meaning. Hint, use the units of measure in your ratio to interpret the meaning. Okay, this is babysitting money. This shows the amount earned for the number of hours worked. Your rate of change is your change in your y's over your change in your x's, or rise over run. And I picked 2.00 and 2,16. I had to rise up a total of $16, and I ran a total of 2 hours. $16 divided by 2 hours gave me $8 per hour. So what that means is that babysitter is earning money at a rate of $8 per hour. Okay? Let's go on to number 20. This one right here, your rise over run. I went from this point to this point. I did not rise at all. My run is 4. 0 divided by 4 is 0. So my rate of change there is 0. You guys are on your own to do the bonus. Good luck and do good on your exam.